The next two questions are exponential equations, but these are the simpler kind. You don't have to use logarithms here because in both questions you can simplify down to the same base. So that's the first thing you want to check. So there's a few different things we can do here. 16 is a power of 2 and it's a power of 4, and so is 64. So we could simplify down to 2 or we could simplify down to 4. 4 might be a little easier. So here we know 16 is 4 squared. So instead of writing 16, we can write 4 squared to the n minus 2. And 64 is 4 cubed. By now you should be getting pretty familiar with your powers of 4. On the left, we know when we have a power raised to a power, we can multiply the exponents. So this is going to be 4 to the 2n minus 4. On the right, we have 4 cubed. And what we learned is if our bases are the same, then the exponents have to be equal to each other, which means the exponents, 2n minus 4, has to equal 3. And then we solve. We add 4 to both sides. 2n is 7. And we divide both sides by 2. We get 7 halves. So n equals 7 halves. Over to number 10. Once again, both of these have to do with 4 and 2. We could go to either one of them. And there's actually a couple of different ways to even do that. I'm going to do it one way just to remind us of negative exponents. So since 16 is in the denominator, this is 4. 16 is 4 to the negative 2. So 1/16 is 4 to the negative 2 because a negative makes something go to the denominator, and that is to the 3x power. And over on the right side, this is 4 to the negative 1. On the left, we'll use our power property, so we multiply negative 2 times 3x, so that's negative 6x equals 4 to the negative 1. And once again, since the bases are the same, and they're not always going to be 4, I know in these two questions they are, the bases are the same, so the exponents must be equal to each other. So negative 6x has to equal the exponent of negative 1. Divide both sides by negative 6, and you get 1/6. So x equals 1/6. And that's how you solve those two questions.